we had looked at some situations where we could use recursion, and we had seen a few examples of how we could do sum of elements using recursion, how we could do search in a list using recursion. I think the last thing we did was we said how do you determine length of a list using recursion. So we did a few 4 or 5 sums on recursion on this. Now we'll continue. So today we'll do some more examples with lists. We will not use recursion today, but or we might use recursion in 1 or 2 problems. But some of the things we are going to do today can also be done using recursion. I'll point it out where you could use recursion. And again, at the cost of repeating, the mastery over recursion is a necessary skill, and please focus on how you think about recursion, because we'll use recursion in almost every data structure session or every data structure that we'll discuss. Whether it is a list, whether it's a tree, whether it's a graph, or any kind of, or an array, we'll have to use a lot of recursion. And yeah, you'll have to get familiar with it. It comes slowly, but it is important that it gets used. So let's start with an example. Now I think we should give you the practice question. Okay, so if you open your system, you will see a practice lab 6, which is what we did in the last session. So please pick it up, because we always extend from the point we are doing. So please ensure that you have it with you, practice lab 6, and you are able to see the code. No, yes, are you able to see the code? In practice lab 6, the existing code that we did in the last class. Okay. We are giving it to you so that you will get to it, you will understand it, you will think about it, and hopefully you will master it. Now we'll take one more example further so that you get more familiar with lists. Now I'll describe the example first. I'll wait 5-10 minutes to see if you can do it on your own, and then we will do it. Okay, it's a small piece of code and not very difficult to write. So here is what we're going to do. So imagine that you have a linked list of some kind. So let's say it is 10, 20, 30, 40. So this is a linked list. And then there is another linked list of, let's say, 52, 14, some arbitrary linked list. So at the moment, we are not asking you to do anything. Now, let's say this is L1, this is L2. So you're supposed to create 2 linked lists with some arbitrary numbers. There's nothing special about these numbers. And we will say L3. So linked list, the line which you have in your main is linked list L3 is equal to L1 dot concatenate. So you are writing a function called concatenate on your list, or a method called concatenate on your list, which takes another list L2 as a parameter. So L1 dot concatenate L2. So L3 is produced by concatenating L1 and L2, which means that L3 will be 10, 20, 30, 40, 52, 14, 12 in this example. That will be L3. So when I say L3 dot display, okay, L3 dot display, I should get all these numbers in this order. So, no, don't write an L3 dot display L1.display followed by L2.display. No. You have to concatenate these two lists, produce a third list, and then say on that list, if I say display, I should get a display of these numbers. So you have the code, please make changes to that code only, or if you have your own code, you can try with that. And so I would prefer if you take this code and add it. I have given you how the method signature is going to be used. So it's a very easy question, it should not take more than 5-10 minutes. So please give it a shot and then we'll move on further. Well, that was the one we used for recursion. I'm asking you to return a linked list, not a node. That is okay at the moment, but linked list, returning a linked list is, you have to instantiate a linked list, will its node, will its, you know how to create a linked list. You read a, okay, now maybe, so what is a linked list constructor having? It's only one constructor. Linked list constructor. So you have to create an empty linked list and it set its HPTR to that node point. 51D. Yeah. You have to return, give me a linked list back on which I can call display. So how do you create a linked list? Your initial concat method is giving you the head pointer. So you can create a linked list which is initially empty and set the head pointer to whatever you just got. That will do the trick. See, we want a linked list back. We don't want just a node pointer back, so that we can call display on it and it will display all the nodes which are there in the linked list. Look at my signature of my method. I am asking back a linked list, so you have to be little careful and return that. Okay, so let's do this. I think we can't waste more time than this. What will we do? So now let's look at the structure of this. So look at the structure of this. This is L1. That is the concatenate is a method called on the first list with L2 as a parameter, which is the second linked list. So how the signature for concatenate will be? It is called on a list and it has another list as a parameter. So the signature will be, we have that code which is not our own code. So let's write the signature first. So let's write here. So let's write a concatenate. So what is the signature of the concatenate method? It returns a linked list. So let's say linked list. Okay. And we have to decide that it's not going to return a pointer to a linked list, but it's going to return a new linked list object. Okay. So how do we create that? Well, it's easy. So we will say concatenate and it takes one parameter which is the other linked list. So it works on one linked list and gives the other linked list as a parameter. So its parameter is also a linked list and which is, let's say, L1, call it L, whatever. You can call it whatever you want. Now, first, is everybody clear about the signature of the method? So the signature of the method is, what is it going to return? What type of object is this going to return? Linked list. Is it going to return a pointer to that object? No. We are going to return directly that linked list. You can also return a pointer, but we'll come to that later. But we don't want a pointer, we want a linked list itself. So linked list is the return value. What is the name of the method? Concatenate. How many parameters does it take? Just one. Because it is called on the first linked list with the second linked list as a parameter. Correct? So that's how it means L1 dot concatenate L2. So that is what we are saying. It is called on L1, so it has direct access to all the L1 data. And it is passed a parameter L2 or another linked list. It's passed as a parameter. So think a little. Is everybody clear about line 150? Do you all agree line 150 is what we are asking for? Okay. So now let's get into the business of creating. So what do we need? We have HPDR. If we say HPDR, whose HPDR are we talking about? First linked list, on which the concatenate is called. So if you compare it with that L1 dot concatenate L2, when I say HPDR, it is referring to HPDR of L1, isn't it? The method is called on L1 with L2 as a parameter. It's not that difficult to understand. So when I refer to the variables by their name only, I am obviously referring to the variables of the class or object on which the method is called. That is L1 in this case. So I am referring to the data of L1. So I will say node star temp is equal to HPDR. I will simply say HPDR. So whose HPDR is this? L1's HPDR. Does everybody agree with that? Because L1 dot concatenate L2. So it is referring to L1's HPDR. Okay. So I am positioned at the head of the first list. That's not going to help me. What do I have to position myself at? I have to position myself on the tail of the first list. Then I can add the second guy directly there. Correct? So that's one step. So first I have to reach the tail of the first list. How do I reach the tail of the first list? That is, I have to reach the last node on the first list. We already discussed. How do we go to the last node of a first list? We have to write a loop. We don't want to go beyond, remember? We want to go to the last node. So what will be our logic be? While temp next not equal to null. That is how I reach the last node, because the way I identify the last node is its next is null. That is how I identify my last node. So I have to, till I have not reached that last node, I keep crawling forward. Okay. So I will say while temp next not equal to null, what should I do? I should just say crawl forward. Temp is equal to temp's next. Every time I move one step forward. So temp's next. I am done. Correct? So now where is temp? Temp is on the last node. When it comes out of the while loop, its next is null. That means temp is pointing to the conceptual tail of the list. Yes? Temp is sitting on the tail of the list. Its next is null. That is how we define that. But now, what is left? Just one line. One tiny line. What is that line? What is the line I add after the while loop? Temp's next equal to else HPDR. That's it. So how do I do it? Temp's next is equal to L dot HPDR. Remember, all variables are public in the class, so that's how I can access HPDR of L. So L dot HPDR. Is everybody with me on this? No, yes. This is trivial. If I go to the tail of the first list, concatenating means, I told you, it should have the elements of this first and the elements of that next. How do I do? Temp dot next, the last node's next, should be equal to the next list HPDR. Okay. So then I am corrected. I have tied the two together. If you visualize it, it's like I go to the tail of the first guy and take the head of the next guy and tie it together. That's how the concatenation is going to happen. That's it. And then I can't return, remember? Just like that. I have to create a new linked list. How do I create a new linked list? I just say linked list. So I say linked list LRES, result linked list. I call it whatever you want. So LRES, that this creates an empty linked list with its HPDR currently set to null. Remember, we don't have a constructor on linked list, so an empty constructor means automatically it can get created. Okay, so this is how we create. Just like you create a variable. If the constructor had parameters, I would pass it. But my constructor, there is no constructor. So it's an empty constructor. So it will. So right now, if I ask you, what is lres.hpdr, what value will be? It will be null. Is that what I want it to be? No. Its value should now be L1's HPDR. Correct? Now, some of you will not agree with this because what we have ended up doing is we have changed L1. Are you with me? We have changed L1. Do you agree? So, a better argument than this would be, your L1 itself is changed. So why don't you return L1 only as L3? By the act of concatenation on L1, L1 has got modified. Do you agree with this? L1 itself has got modified. Because L1's tail, which was earlier null, pointing to null, now is tied to the other list. So L1 has got modified. L2 has not. L2 is as it is. Okay. That is because I have not done anything to L2. But L1 has surely got modified. So maybe I should just say 156, so remove 156. I will just say return the current object itself. Now here comes something from basic C++. Okay, let me think about this. And are you familiar with this? Has your C++ progressed? You are running C++. Not all that, but doesn't matter. In C++, there is something, a special thing called this. THIS this. And wait 3 minutes, 5 minutes. Just see what is this on the internet for C++. And then tell me what is this. The this, THIS this. Okay, you tell me what is this, and I am going to use this. Pointer to? So pointer to object, which object? Do you see a line there? Pointer to the current object. Who is the current object here? On whom are you working? L1 or L2? L1. So for us, right now when we are doing this code, in our interpretation, L1 is the current object. You agree with me? No. Not L2. L1 is our current object. Now, this is a pointer to the current object. That means it's a pointer to L1. Are you expected to return a pointer to L1 or are you expected to return L1 itself? L1 itself. How do you go from a pointer to what it is pointing to? You say star. Oh yes. If I give you a pointer and I ask you, what is it pointing to? What value is it pointing to? How will you get me that value? You will dereference the pointer. How do you dereference the pointer? You say star. If you put star before pointer, except in the declaration of course, you will get the value which the pointer is pointing. So what should I do here? Return star? Star this. You agree with me? You just say return star this, then you are returning not a pointer to the current object, you are returning what? The current object itself on which you are operating. Which object are you operating on? L. So we will say, do all of you agree? Looks a little strange, but you have to get used to it. So this is a pointer to the current object. Star of this is the current object itself. So I am saying star of this because I said I am not going to return a pointer to the resultant list. I am going to return the resultant list itself. We decided that once L1 has been concatenated, L1 itself is the result. Which is fine. A lot of things have that. Especially concatenation has this because when you are asking something to be concatenated with me, I am changing. And I have to be returned as a result. So, because that's how the signature looks. So, return star this. Return star this. Okay. So, does everybody agree with my concatenation? What am I doing? I am taking a linked list as a parameter, okay? Linked list object as a parameter. With that, what am I doing? I am saying h temp is equal to hptr. I am going to the end of the current list on which this second list has to be concatenated. Then I am reaching on line 54. I would have come out, I would have reached temp would be positioned at the tail of the first list. Once I am positioned at the tail of the first list, what am I doing then? Temps next, my tails next is equal to else hptr. L has an hptr, we know. Every linked list has an hptr. We are connecting them together. And after that, we are returning star of this. Let's see if it works. Okay, let's go down. We'll say linked list L1. We'll call it L1. This creates an empty linked list. Okay. L1.append. Let's add some two values, 10 and 20. L1.append 10. L1.append 20. Okay. Then let's say L1.display, the old display. L1.display. Then we'll say L2.append. We'll create L2, sorry. Linked list L2. L2.append. Let's say 15 and 25. So we'll do L2.display. So we have displayed L1 and we have displayed L2 after creating them. Now let's say L3, linked list L3. Because the result of this operation is a linked list, L3 is equal to L1 dot concatenate L2, and then we'll say L3 dot display. Let's make an attempt to run this code and see whether it works. Okay, we'll just clean it up. See out. First list. And then second list. Result list. There is a concatenate list. Okay. So let's see what we get. So I think now it can be seen clearly. First list is 1020. Second list is 1525. So the result list is 1020, 1525 as expected. Do you understand what we did? This is how you can create a linked list, which is a concatenation of other linked lists. So let us now do a little bit of jugglery here with C++, concepts of C++. So I am going to show you that. Okay. Now, because this is the right time to show you that. Okay. How did we write line? Focus your attention on line 186. So focus your attention on line 186. I am going to do something to this line so that you understand something more. Do you like this line? Now you'll ask, what is there to like or dislike? Is it some Cadbury or chocolate to like or dislike? No. What I say to you is, what are you doing? In essence, you are adding two lists, producing a third list. Correct? Now, would you like this kind of a syntax, or would you like something else like this? L3, linked list L3 is equal to L1 plus L2. Which one would you prefer? What are we saying now? L1 dot concatenate L2. I'm sure since kindergarten you have learned this thing that if I put plus between any two things, somehow they get added. This is your basic intuition. All human beings who have grown up to age are expected to develop this intuition that if you put plus between any two things, they somehow get added up and not subtracted or multiplied, right? This is something which 10 plus 2 education is supposed to provide in the least. So now, can't we do something similar here? You understand what I am saying? Can't I say linked list L3, same syntax, same thing, L3 is equal to L1 plus L2. Sorry. Wouldn't you like that? Isn't that more intuitive or no? I somehow think that is more intuitive in this case than L1 dot concatenate L2. Nothing wrong with L1 dot concatenate L2, but somehow I would feel more comfortable doing it. If I were to do that, what should I do? Okay. Anybody? Somebody who is reading C++ in advance? Nobody is? Operator overloading. In C++, you'll soon learn there is a concept called operator overloading. What does it mean? What is the operator involved here? Plus. I think there is no surprise there. Overloading the operator means what? Giving a new meaning to that operator for my class. So, I am going to define what operator plus means in case of linked list. For the linked list, what is the meaning of plus, addition? C++ allows me that kind of freedom, which C doesn't, to basically treat operators the way I want them to be treated on my classes. Now, I'm not going to convert this into a C++ class, but I'm just going to show you the same logic. It's a old wine, new one. So instead of using concatenate, I'm going to rewrite the same method, exactly same code, and I'm going to produce and write it using what is called operator overload. This is a big word, means something very simple, and you will soon see that what I'm doing. Okay, just observe first, then we'll think about it and see what we are doing. So I'm going back. So I want to write instead of 186, let's comment out 186. So let's comment out 186. In place of 186, let's write linked list L3 is equal to L1 plus, and this plus is just like the plus you learned from kindergarten. Okay? There's not anything special I am putting in that plus. Okay, plus L2. That's all. And I want the result to be as it is. I want this to work. As of now, it won't work. If you try to compile it, and some of you should try, it won't work. Because right now, our linked list doesn't know what the hell is operator plus. It doesn't understand operator plus because you have not added that intelligence into the linked list that it can interpret operator plus for itself. Okay. So how should I do that? How should I enable that to happen so that rather than using 186, I can use 187. Okay. And this is the power of overloading. Okay. I'm adding a meaning to the plus operator for my purpose. Okay. Let's see how I do that. I'll go right at the top where I define concatenate. I will write one more method after that, and I'll borrow exactly the same code, or more or less the same code. So I'll say what my operator plus should return? Linked list. Okay, yeah, borrow the same signature. Let's make changes. In fact, borrow it again. Yeah, just copy it again. So, let's focus on that word. Okay, I'll just say, in place of concatenate, I'll remove the word concatenate, and I'll have to say plus, but when you write the body for it, plus. This is how you write operator plus, plus. Linked list, operator plus linked list as a parameter. I am not changing anything. I am not changing anything in the method. I am not doing anything else. What I have changed is only the nomenclature, only the name of the method. Instead of calling it concatenate, I have decided to call it operator plus. Yes? No? Everybody buys this? So, this will give me a much prettier way of calling concatenation than saying dot concat. It's just as we call it in computer science, it's called syntactic sugar. Syntax wise, this is more sugar version than the older version. That's why we call it syntactic sugar. Okay? So anyway, that doesn't add any value. So let's do it now. Remember, I am not calling concatenate, I am calling plus. So now let's try our luck whether we get what we want to get. Okay? Oh no, let's run it. Okay. Now you see, look at my last line, last part. My result list has not changed in any way. Because I am not doing anything else. Only thing is I am getting away with an easier semantic representation of plus than the earlier one. Nothing wrong with the earlier one also. You are free to say concatenate also. There is nothing wrong. But plus looks better. Now, do you understand a little bit why operator overloading is there? You can do this with other operators also. Plus, minus, divide, multiply. But for a linked list, I can't think of what would divide one linked list with another linked list would mean. I'm sorry, I don't understand the interpretation, right? What do you mean by dividing one linked list with another linked list? You can divide a linked list perhaps by a number, but then the interpretation is very vague. Why? It could mean each value in the linked list is divided by the number, or the linked list is cut into 3 chops and given to you. Wherever ambiguity of interpretation is there, operator overloading may not be a good thing to do. In fact, and since I am there, operator overloading is there in C++, was taken away by Java people. They said it is causing more confusion than benefit. So, while you can do this in C++, when we will do Java with you, I will tell you exactly in the same way. This is not possible to do in Java. Why? Because Java people believe this is creating more nuisance, because plus may be intuitive. But minus, what do you mean by minus linked list? Are you going to say, get me all the elements in this linked list which are not there in this linked list? Or cut this linked list and do something which is subtraction on the linked list? The meaning is not very intuitive or obvious. So they said that this meanings, because they can change based on interpretation of a person, and there is no one way of doing it. Let's get rid of operator overloading in Java. In C#, it is there, but it's kind of saying, if you want it, add it, otherwise forget it. Okay? Python has a completely different view. We'll come to Python soon. That's another interesting thing. Okay? But not right away. We'll come to it slowly, soon. Okay, what do they have to say about operator overloading? And please, when you study a language, your curiosity should always be there that, oh, this guy has this, what does this language say about this? Stack Overflow is a mother. Now, those of you who are there, who don't know what is Stack Overflow, my sympathies with you. Okay. So, people live the tech, or you will soon start, 3rd year, 4th year, you will have to live on Stack Overflow. Because the Stack Overflow is gone, it's like petrol gone out of a car. So, look at solutions. So, one thing is, what does Python say about overload? And since you are studying both the languages, you should always explore. Not now, we'll do it complete one by one. Now, we talk about another feature which we'll add today. It's not a feature, it's more exercise with linked list. We'll learn how to reverse a linked list. And we'll do it in 2 ways, hopefully. Okay. Do you know what is reversing a linked list? its tail should become its head and vice versa. Right? So, and it should return the head point, or it should change the head point, whatever. Okay? So that the list becomes reversed. It's an interesting operation, so interesting that most people copy it from somewhere. Okay? No, please don't. We are going to write two versions of it. Okay? We are going to write a linked list version, and we are going to write a regular iterative version, and then we are going to write a recursive version. Now the recursive version will take a little bit of thinking, but you should develop your mind to think in that way. So let's write the non-recursive, that is called the iterative, that is you go through the loop. Iterative means what? Whenever you see a for loop, it's iterative. Whenever you don't see the for loop, then it is recursive. I mean one hint of what recursion will do. Okay, so we will have, let me write the main for it first, and then we'll write the code for it. So I will write something like this. L3, since L3 is there, L3 dot reverse, just that. And after that, if I say L3 dot display, it doesn't take any parameters, it just reverses itself and updates the HPT. When I do this, I should get the result list as, obviously, if I have 10, 20, 15, 20, 10, 20, 15 and 25, what should it print? 25, 15, 20 and 10, correct? That is what it should print if I have reversed it. How will I reverse it? Okay. Let's think about it. And please don't, even if you copy it from the net, understand. To understand what's the code, we will understand, then you can easily do it. Okay? But it should work the same way as I have written. Okay. How do you go about reversing a linked list? Okay. Let's think about it and we will do it. So let's say L1 is something like this. First, I will tell you what to do. You give it a few minutes, and then we will write it together, or we'll write it, for those who are not. Okay, the trick is, what should it look like later? It should look like, this stays where it is. And 30 should point to 20, or the node 30 should point to node 20, 20 should point to 10, 10 should be null, hence next should be null. Do you all agree? This is the reverse form of this list. Do you agree or not? Or if you don't agree, agree with me. This is how reversing will happen. Okay. Now, let me think with you, or think with me. What should I do? Okay. Well, the trick is very simple. You maintain one extra pointer besides temp, which is a pointer to the previous node. Because remember, when you are doing something to, let's look at 20 as a sample node. Its next must actually, so you are going through the list forward. Okay. If you keep track of who is your previous guy, then only you can modify this guy. No, yes. So, as you go through the list, if you keep updating your previous and temp anyway you know how to update as we go forward. But you have to update this previous guy. And what is the previous guy used for? To keep a pointer to the node that you just visited. Where you were just now, before you shifted to the next node. You agree with me? You have to keep track of the previous guy, because now this chap, temp, wherever you are, his next should be previous. And before you do that, you have to store this guy's next somewhere, because you are updating this guy's next. So there are 2-3 activities you have to be careful. Let's just think you are on this node, you have reached this node. So your temp is here, because you are going through it one by one. Okay. Now you will have to maintain this guy's next. Remember, sorry, you are not going through this. I am sorry. You are going, because we have this list. So let me call it T. My T is here. Let's pretend my T is there. So when my T is on a particular node, what all do I need to do? I now need to say something like this. I have to first preserve this guy is next, because that is what I am going to use to move forward. No, yes. So I have to first, because if I lose that, I can't move forward in the original list itself. So I have to say, generally they use cur. Cur is equal to, or you can even use next. You call it whatever you want. Next is equal to T's next. I mean, this is next. Let us call it N. N is equal to T's next. Where is T? T is here. Do you first buy this? No, yes. T is equal to, N is equal to T is next. This is going to be the next pointer. This is where I am going to go next. This I have to preserve. Otherwise I can't move forward. No, yes, lost me. Think a little. I have to keep this guy's next with me. Just imagine I am here. Then I have to have a previous. So that previous, so T is next. I have captured this pointer, so I know how to move forward. Now I am free to update T is next. T is next is equal to previous. So T is next is equal to previous. Previous, imagine, is pointing to this. Somehow previous is pointing to this. Okay. So previous is here, T is here. So what did I do? N is equal to T is next. I have preserved the next pointer, and then I am saying T is next is equal to previous. What should happen to previous? Previous should also get updated now. So I should say previous is equal to, where should previous be? T. Because in the next step, this guy is going to become previous. Previous is equal to T. And T is equal to T is next. Oh, I forgot to use, oh no, T is next has come. So sorry. T is equal to N. Yeah, T is equal to N. So there are, now just see what I am doing, and I keep doing it till T is next is not equal to none, till I reach the last one. Okay, just watch. I am preserving the next pointer in N. I am taking that. This is just you can think of a placeholder. So the next pointer I am preserving here. So the pointer to this guy I am preserving, because I have to update it accordingly. Then T is next, that is this guy, T is here. T is next is equal to previous. Now I have set this guy is next to previous. Now previous should become T and T should become N, which is earlier T is next, which I have preserved. So these are 4 lines I need to do. Okay. Correct? Huh? No, think logically. Do you understand when I say memorize? T. T is on that 20. Okay? And imagine some way we have a prev. Okay? What is prev pointing to? Prev is on 10. Are you with me? Just imagine forget how we reach that situation. You are on 20, T is on 20, and prev is on 10. Am I right? No. Prev is on 10. So what should you do? In order to just reverse this part, just this small part, the 10-20 part, okay? What should you do? Now, T is next, I cannot lose. Do you at least understand why I can't lose T is next? If I lose it, I don't know how to go forward because it is this N which I am preserving, which will allow me to go forward. Are you with me? If I lose N, I have lost my forward path. I can't go through this list only, forget reversing. So, I have to keep that N somewhere. Sorry, T is next somewhere. Sorry. So, I have kept it in N. Okay, before I overwrite it. Then I have to say, T is next. I can overwrite it now. Now, I have to alter this animal T such that its next goes somewhere else. Where does it go? To the previous guy. Because remember, my list needs to get ulta, reversed. So it has to get to the previous guy. Okay. Then, what should the previous guy now become? For the next iteration, you are now getting ready. First two are things which you have done for this step. Now you have to get ready to move to the next guy. When you move to the next guy, what should you do? Your prev should be now T, where you are. No, yes. Logical, no. Prev should become P. Would you agree? And your T should become N. What is N? Next guy. Remember, that is why you have to keep N. Now T is the next guy. Did you understand these steps? No. I am on T. My previous guy is prev. Call it P if you want. I am getting a reference to my next N. N is T is next. Then I overwrite my T is next to become pointing to previous. It should lead me to the previous. The pointer to the previous. It's going to be my next pointer. Then these are the steps I do for manipulation of this node. Then what do I do? Then I say prev. I have to update prev. Prev is now the current T. And T should go ahead to whoever is the next in the original list, which I have preserved. If I say P next now, I will go to previous. So I should do that. I should say T is equal to N. And then how long should I remain in this loop? Till I reach the tail. How do I know I have reached the tail? T is next is null. Till T is next, while T is next not equal to null, I should keep doing this. Okay. And in the beginning, where should prev be? Outside the loop. Prev, where should it be? Prev should be null. In the beginning, where should prev be? Null, no. There is no prev. It is null. First node is next. Imagine now. Tens next. Where should it go? In the altered list, in the reverse list, tens next. See the picture. Where is it going? Null. That will come from prev outside the loop. No. First time prev is not going to be set by anyone. So we have to set it. Yes? Okay. So shall we give it a shot? Shall we start writing it? You please think, understand and then write. Okay, we are writing it. So let's start writing it. Okay. So let's write the result of the linked list is nothing. It reverses the current linked list. So I write a void. Because the same list gets reversed. I am not going to return anything. Okay. So void reverse. Node star, you need a bunch of pointers, so we'll have that. So n is one, brev is another, and t is another. Okay. So I'll declare star t, comma, star, star p, preview, so take. Now we'll put it in separate line, semicolon. No. I'm just declaring 3 pointers. Okay, I'll make prem equal to null. And I'll make t equal to head, HPTF. T equal to HPTF. And n I will not initialize to anything in the beginning. Because I am starting at HPTR, no? Okay. So I will say now, while I have not reached the end. So while t is next not equal to null, while t is next not equal to null. Okay? This is where I am. Does everybody agree with me so far? Whatever I have done outside, I have not done anything. I have just made t point to the head and previous equal to null. That's all I have done. So imagine I am on the first node. Okay? What should I do on the first node? First, I should get a pointer to the second node and keep it somewhere. Correct? So let me grab that pointer. So I will say n is equal to t is next. I can't afford to lose this. Do all of you understand this line? Why am I doing it? If I lose t is next, because I am going to put something else in t is next. So the original t next will be obliterated, overwritten. If I lose that, I'll keep going back. Okay. I have to go forward also in the list so that I can orient it appropriately. So I am saying n is equal to t is next. So I have preserved where t is pointing to next. Then that means it has a next. Okay. So yeah. Now there will be a small one. It doesn't matter. N is equal to t is next. Then t is next is equal to prep. Okay. Because now the new t is next should be equal to prep. Would you agree? Then I should now make t go to the next guy. So I should say t is okay. I can update prep first. Doesn't matter which order I do now. Prep is equal to t. Prep is equal to t and t is equal to n. Okay. Now I have a small bump. Can you tell me what? T? Good. I should go beyond the list, isn't it? If I stop at the last guy, it won't be correct. So my while loop, just imagine, when I reach 30, 10, 20, 30, 30's next is not equal to null. Sorry, 30's next is equal to null. So I will not process 30. Are you with me? But I want to process 30, no? Oh yes. I have to handle 30 also. My list is 10, 20, 30 please. If I stop at next not equal to null, I will not process 30. But 30 also has to be processed. Correct? So I will say while t not equal to null. Next. T not equal to null. While t not equal to null, because otherwise my last node will not be processed. Now my last node will be processed. But now, okay, there is one line outside the loop I have to do. What is going to be my HBTR? Very good. So when I come out of the loop, my n is not, or my t is not going to be HBTR. T is null. Yes, no. When I come to the out of the loop, my t is going to be null. Otherwise, why will I come out of that loop? I can't use t as my head. It will be null. What should I use as my head? Previous. Isn't it? Because previous will be pointing to the earlier node. The trick is somehow I have to ensure that prev points to the earlier node. So I should say HPTR outside the loop. I should say HPTR is equal to prev. Am I done? Have I done a reverse? Okay. Well, I'll pause a minute, 2-3 minutes. You take a list. Now, I really want you to do that. Take a list 10, 20, 30, whatever, and see whether this code is working or there is a malfunction. Just do it manually in the sense, see what happens with each node and how do you go forward. Just take a small list, 10, 20, 30, and convince yourself whether it's working or not. And tell me whether it's going to work or it's not going to work. Okay. Is everyone convinced that it's working? Yeah, it's working because it's written logically. Okay. Now, let's try a recursive way of writing this. I think I've run out of time, so I will not be able to give you a complete thing. I'll take it up, start now, and we'll finish it in the next session. So, but in your mind, visualize reversing. The size of the code is going to reduce, as happens with recursion all the time. Now, if you think, how do you think about recursion? If I know how to solve n-1, a smaller list, smaller by a single node. So, if my list consists of n nodes, which is what, let's say, this list is, or if my list consists of 5 nodes, if I know how to reverse a list of 4 nodes, that is, from second node till the last, can I not reverse the rest of the list? That's how you are supposed to think in recursion. Think of a smaller problem, smaller by one step, one size. So my problem is what? I have to reverse a list of 5 nodes. So I have to presume or assume that I know how to reverse a list of 4 nodes. Using the list of 4 nodes intelligently, reverse of 4 nodes, can I just by a little tweak add a little more and get a reversal of 5 nodes, list of 5 nodes? Okay. Let's think about it. So imagine I have a list of 5 nodes. My list currently is this. Now, let's imagine that I have managed to reverse this list. That's how recursion asks us to think. So, if this list has recursed, how will it look? This list has reversed, how will it look? Imagine this is already reversed. How it happened, don't worry right now. So this has reversed. Yes. And you obviously have a pointer to this guy. If it is reversed, you should have a pointer to the head. Just now we did also. Correct? No? Yes. Now, what should it, so if you have reversed this part and got a head, what should you do now? I have not reversed this. This portion is reversed. And this is right now none. Is my head at the right place? Is it or not? It's at the right place now. But do you agree or not? Is my head right place or not? From the final answer, is my head at the right place or not? It is. You agree or not? Head is at the right place. Where is the head? Head is on 50, no? When you reverse 20 to 50, is head on 50 or not? It's on 50. Just assume it is reversed successfully 20 to 50. Now, I have HPTR on 50. Correct? And what I have to do now? If I have that, and somehow if I make my reverse, give me the tail point somehow as a return value. Oh yes. Somehow at the end of the reversal, if I write the reversal intelligently and make it give me the tail loop pointer, H is anyway reversed. So no, just give me a pointer to the tail. Yes? What is the pointer to the tail? You don't even have to give me. The earlier my next. If I am on the first node, imagine I am on the first, think a little please. If I am on the first node, when I reverse from second node onwards, who will be the tail of that second node onwards list? My first guy is next. Imagine you are on 10. Imagine you are on 10 and you have asked for the rest of the list to be reversed. Are you with me? I have asked for the rest of the list to be reversed. When the rest of the list is reversed, it will look like it will start at 50, 40, 30, 20. So, the tail of the list will be who? Earlier next will be the tail. So, if I have preserved that, or after reversal, that is what would happen. Okay. My next will become the tail of the rest. The rest of the means 22. So, if I do a little bit of surgery there, little bit of operation there, small procedure there, what should I do? My next, which was my earlier next, his next should become me. Oh, yes. I am T, let's say. T's next was 20. Earlier. But I did reversal on that. Now I know I have to manipulate T's next. Earlier T's next, which I have preserved. So T's next T. Is next. Next. New next of T is next is T. Does this line make sense? T is next. Earlier T is next. Next. That is this node's next. Should become T. And my next, that's T's next, should become null. Oh yes. My next should become null. I'm done? Because my next has to become null. I'm on 20. Sorry, I'm on 10. I reverse the rest. So, when I reverse the rest, see, when I ask for the reversal of this, I have already preserved the pointer to this guy. So, I have with me the pointer to this guy. Okay? And I have this guy. So, what should I do? This pointer. What is this pointer? The earlier T's next. Next is equal to myself. So I have to take this thing out and then do this. So I have to call reverse intelligently and then do this. Okay. Now I think we have run short of time, but this is what we'll start with in the next session. So think about it. It's not very difficult. Little bit of imagination, little bit of creativity will take you to a recursive version of the linked list. Then, I have not yet described the termination condition. When does the head change? When the list has only one node. That time the head should change. So you have to write that terminating, because recursion, you have to also write the terminating conditions. Correct. Okay. So this is just to give you a forward thinking. So those of you who are interested can write a reversal in recursion. Using recursion, write a reversal. One. Okay. And then, okay, let's stop here. We'll do the continuation in the next session.